previous presentation, we have mentioned how the leaning and twisted glass facade was constructed. From cutting, assembling, and attaching those to make the facade, it gave continuous stress to the constructors. But they couldn't stop what they had started to realize the architecturally impossible building like the Sultan required. This leaning and twisted facade makes Capitol Gate Tower realize a breathtaking appearance from the outside. This facade is magnificent in design and structurally carries out an important role. However, surprisingly, this facade actually plays another important role. It is helping the tower endure the hot and harsh climate of Abu Dhabi. The climate of Abu Dhabi is subtropical and dry with high temperature. The summers from the month October to May, the temperature will be typically above 40 degrees and will reach 50 at times. Considering that the upper part of the building to be a 5-star hotel, it was crucial to maintain comfortable and cool temperature inside the building despite the outer environment. However, relying only on air conditioning would be a waste of energy and take an immense budget. It would also make it impossible to become a sustainable building, which is one of the important trends of latest buildings. As the Sultan wanted Capitol Gate Tower to be an iconic building in many ways, this would become a scratch to the reputation, and Sultan would not be satisfied with this. So, they had to cool the building using minimum energy, and the facade was responsible for this important role. First characteristic of the facade to help cooling the Capitol Gate Tower is the lean. In the constructing process, the leaning design always the engineer's struggle, but regarding the energy aspect, this leaning feature gave advantage to them. With this leaning characteristic, Capitol Gate Tower could control the amount of first coming sunlight with related with time and incidence angle. First, at morning time with a little cool temperature with weak strength of light, relatively large amount of sunlight can be casted in because of the low incidence angle. At 4 o'clock, medium amount of sunlight can enter inside the building because of the increased angle with medium strength of light. But at noon, when the sun is most strong, the incidence angle made by the sun and slightly leaned facade makes the largest amount of sunlight to reflect, thereby protecting Capitol Gate Tower from the hottest condition. With the changing incidence angle, the leaning facade helps Capitol Gate Tower to get constantly decreased amount of sunlight with hellish hot temperature in Abu Dhabi. But this was only the first step in doing so. Even with this leaning shape, the facade had to take even special measures to protect it from the merciless hot sun. The glass of the facade used low-E glass to maximize protection. Let us introduce the principle of it. When light energy hits an object, the energy is divided into reflection, transmission, and emission. Since the amount of energy at this time is different for each substance, it is said the absorption rate of an object corresponds to the emissivity of energy. For example, if 100 amount of energy is given to an object, and the energy of 30 is lost through reflection and transmission, energy of 70 remains in the object. Here, we measure the infrared emissivity of the object as 70%. As explained earlier, the moderate hot weather in Abu Dhabi was a very important consideration. Although the facade is made of glass, which has a relatively low emissivity compared to other materials, this wasn't enough to overcome the high temperature of Abu Dhabi. There was a problem using ordinary glass. Therefore, Capital Gate Tower actively used low E glass. Low E glass means glass with low emissivity. It is made by coating a special metal film with high reflectivity on the surface of general glass. The glass made in this way transmits a visible light similar to that of ordinary glass. But since the reflectance of infrared rays is high, heat transfer between indoors and outdoors could be minimized. In particular, Capital Gate Tower used a glass called Low E240, which is special among low E glasses, which reflected almost all infrared rays. Usually, as this particular glass was rarely used because of its relatively high price, Capital Gate Tower was the first building to use this glass entirely on the facade. Low E glass was used to reduce the energy needed throughout the building. Then how was this glass used in the building? From the 18th floor to the top floor of the Capital Gate Tower, low E glass was used in double layers. And these two layers of glass had different shapes. We have explained it that the exterior facade used diamond-shaped glass made up of triangles, which would be the outer of the two layers. And the inner glass used less expensive rectangular glass. This double-layered glass was able to bring advantages to two aspects, which helped reduce radiation energy and ventilation side from the sun's hot light. First, when venting the building, if Abu Dhabi's hot air enters the building directly, the air inside will heat up very quickly, so it will cost a lot to keep the room at an appropriate temperature. However, a primary reduction in air temperature due to the double-glazed space would reduce the energy used for the ventilation efficiently. Assuming that Abu Dhabi's average ambient air temperature is 46 degrees, it can be lowered to about 30 degrees in cavity and then enters the room at 23 degrees Celsius, making much more efficient than entering the room immediately. Also, the air used in the cavity could reduce the energy use of the building by reusing the air inside the cabin. Secondly, this double-glazed system was very advantageous in reflecting the hot sunlight. This was effective in double preventing solar energy by reflecting once from the outermost glass and again from the second glass. Then the 18 to top floors of the hotel could successfully overcome the hot sun of the Abu Dhabi by using double glazing. However, the first to 17 floors did not use this double glazing system. So, how did floors first to 17 avoid the hot sun in Abu Dhabi? Surprisingly, this was solved from the leaning design of the Capital Gate Tower and the additional beautiful structure. One of the Capital Gate's most visible features is the splash, made of a layer of woven metallic mesh stretched over a metal frame. It was designed in the form of wave, connected with the canopy of the adjoining Abu Dhabi National Exhibition Center grandstand canopy. Due to the 18-degree lean in the west wall of building, it was necessary to put measures to the sunlight reaching to the glass. Splash, which was installed on the opposite side of the leaning direction of the Capital Gate Tower, did not only act as a design element, but also an excellent light shielding device. The splash twists around the building toward the south to shield the tower as much as possible from direct sunlight. Mesh facade, which was made with lightweight stainless steel, saved almost 13% of energy maintaining its indoor temperature. Thus, in the hot weather of Abu Dhabi, the first to 17 floors were able to provide enough cool air under the shadow of the splash, even without the double-glazed glass. Therefore, The splash was acknowledged not only for its aesthetic feature, but also its important role for minimizing the energy needed to cool the building. Then, how did the opposite side of the splash under the 17th floor, which certainly did not have the double-glazed glass, protect itself from the hot temperature? Here, leaning characteristic of Capital Gate Tower did a crucial role. Because of the tower's leaned angle at opposite direction of splash, it was able to make a natural shade for those side, and it works as same as the splashes. So, there is no need to install additional shade to cool under 17th floor of the opposite side. By this, with the help of the leaning shape, low emissivity glass, double glazed facade, and the splash, Capital Gate Tower was able to become an icon as a sustainable building with high energy efficiency. Thank you for listening.